welcome everyone to this month's episode of AI Pe Charcha. The intent of these conversations is to continue the dialogue that we started with the RAISE Summit and try to kind of demystify AI and kind of understand how it is. AI is not something which is going to be a technology of the future. AI is here. It's already being used in various government departments, in various states, by various industry partners. And in many ways, the experience that citizens are having by utilization of technologies like AI is much better than what it could be otherwise. It's for us to understand the kind of data that we have, the kind of data sets that we have, how can we leverage these technologies to make user experience better and kind of simplify things better, trying to make our services more secure and trying to ensure that people get more, as we very often say, a better ease of living. So that's the whole intent. Last month we saw certain demos that Microsoft gave, and the lead speaker from Microsoft. Thereafter, it was thought that which are the other government departments wherein AI is being used in a big way with facial auth and with other algorithms, and trying to use the data that is available for helping improve services. And the very value of the very principle of AI that India has adopted, our national strategy on AI, talks of responsible AI. So whenever AI is used, it's used for betterment of services. It's not used for any purpose other than the welfare of the citizens per se. So that's the key role here. Whether AI is being used for Jeevan Praman, or whether it's being used for data analytics and modeling in the DigiLocker project, or in agriculture or healthcare, or diagnosing diseases. Everywhere, that is the key focus about that. So what we need to understand is that AI is happening. It's a application that we can leverage, and there are examples across the country in which different projects, different beginnings have been made, and there is a huge potential and a huge value in learning from each other, sharing our insights, and getting to know what has been done. And if something has been done in Aadhaar, or something has been done with Xstep, or something in any domain, there can be use cases, there can be applications in other domains. So that's the whole intent about this AI Pe Charcha which we do. So I would now request Dr. Vivek Raghavan to begin this session, this month's AI Pe Charcha, with his talk, followed by the demo and the Q&A. So welcome, Vivek.
So first, thank you for giving me the opportunity to talk here. I think I'm quite excited to talk about using different kinds of open source AI to solve large scale problems, right? In India, all of our problems are billion scale problems. So, and I think I wanted to kind of also demystify. I mean, a lot of people, we have had many talks, and I think it is very relevant, which talks about the power of AI and the various things that AI can do. But I think that, but all of those things people hear and say, oh, AI is so powerful, AI can do this, AI can do that. I want to actually take that conversation from a 30,000 feet level to a little bit lower, so that it is not that somebody else can do it. No, the point is that we ourselves can do it, and we can use it to solve our real problems that are there in governance, and AI can be a real contributor. And I want to show two different areas where I have had the privilege of being associated with. One, of course, at UIDI, some of the interesting work that we are doing related to AI at Aadhaar. And the second area is actually some of the work that I've been doing related to language AI at Xstep Foundation. So I think that so therefore you have some idea of the different kinds of ways in which we can use. And one of the core things that we are doing is that we are dealing with both open source data and open source models, and that's one of that's one of the key things that you will keep looking at. That we are not tending. Because of our nature, we have not tended to use any proprietary technologies. So we've been doing most of the things in open source. So I just want to show that open source is also a way to do things, very interesting things in AI, and you can achieve state-of-the-art results in the world by doing these classes of things. What are the things that really, if I'm looking at a citizen and I want to actually provide the citizen a service, what are the things that are needed to actually do that, right? Imagine that we are 5 years from now. Can we actually do everything that a citizen ever needs to do? at their own phone wherever they are with and can every service be provided? Yes, we can do that if we can actually validate their identity, we can understand what they are speaking, we can answer their questions maybe in their own language, and do this while validating whatever the other things they provide, whether they may be documents or whether they may be some other things, and detect different kinds of frauds. And if you actually can do all of these things, then you can actually have a governance paradigm that is very different from what it is today. That means any citizen of the country can access any service wherever they are. And I think that is really any citizen of the country can access any service wherever they are in their own language, and maybe just through a spoken interface. And then you could be able to do that. And I think that all of these pieces are there today, and they are there that they are today. And you can actually leverage open source solutions to actually solve all of these problems at a large scale. And I think that's the big picture of what we are trying to say. And I'm trying to now, from moving forward, I'm painting a big vision, and this is my only Gyan slide, so to say. After this, we will be talking about specific projects where you will see that each one of these things, what is the work that we have done, and what is the work that we have done as part of over the last few years to actually leverage and use open source solutions to actually build real components that are there for to build real components which are really being used within the country. Okay, so I think that I'm going to divide this up into two kinds of projects. The first is the projects that we are doing at Aadhaar. And I wanted to say that this is, and when we use the word open source, it means slightly different in the two different domains that I'm going to talk about. In the projects that are related to Aadhaar, pretty much we always start with an open source framework. And then we have these young professionals who are actually the people who have built these things, okay? And they have been fresh graduates. They happen to be IIT, it doesn't have to be from IIT. And they have actually been hired by UID. And actually we have leveraged open source frameworks, studied state-of-the-art research papers, and built systems that have actually now meet the state-of-the-art requirements. And of course, in these cases, the IP is actually owned by UIDAI, which is Government of India. So therefore, that's just and so therefore, it is in many ways, this is an interesting way that it actually is like we are talking about Atmanirbhar AI. So we are actually building this. It is owned by the government. It can be used for whatever purpose. And today it happens to be inside UID, but I want to show that just using open source and having some smart young kids there, you can build, what can you build and actually build core technologies which are open source technologies which can be used for any purpose. Okay. So now after this, and then the second step will be the eighth step, which is the principles are slightly different there, and I will get to that when we talk about eighth step. So I think that the first thing that we are going to talk about and is actually what Abhishek sir started off with is actually we have this face authentication is actually a new is UIDAI has internally developed deep learning based face authentication based on a number of open source frameworks. Our accuracy that we are achieving are actually on par with the global state of the art. And we are actually having pilots in various things. Actually, I put COVID twice. Pilots in AEPS, pilots in attendance, pilots in CoWIN. And it actually is at a very highly scalable action. Even already we are ready to do 1 crore authentications, face authentications a day. But that's just a hardware thing. We can scale to much bigger than that. And the goal, actually, one of the focus is that face authentication will be included in all of the Aadhaar services in the future. I think that it's a couple of interesting things that, it is not just, the face authentication system is not just defined to be actually it's two things are very critical. What is the accuracy? We are achieving actually on UIDAI data, we are achieving 99.4% accuracy as far as the face authentication is concerned. And we also have a very large number so it's both highly secure and highly accurate. And at this stage, maybe because this is all I'm going to talk about face authentication today, but I'm just saying this is again something which was built, you starting from open source and then built upon by our young professionals. So therefore, I will now request Sachin to actually give a short demo of this face authentication before we move on to the next place. So
yes, so this is the Aadhaar attendance application. I will here now enter my this attendance ID. It is the reference ID of my Aadhaar number.
So many of you who use the attendance app will see this is the same attendance app that we have.
Now the app is asking for me to blink my eyes. As soon as I blink my eyes, it will capture my face. So here, authentication is completed. The attendance is marked.
Face authentication is something which is now actually is available in production in Aadhaar. It works in a number of applications being piloted at a number of different places. And clearly, this is another method of authentication, which is actually extremely valuable, both in these kind of the non-touch situations, but also very valuable for senior citizens. One of the things that we see is that for senior citizens, we see as a very effective way of authentication. The accuracies of face authentication are significantly better for senior citizens as compared to fingerprint. So, so therefore we see as rolling out. And one of the interesting things is many of the Aadhaar enrollments actually happened a few years ago, but our face authentication extremely strong. So therefore it's actually able to even understand the changes in the face and authenticate even in spite of that with a high rate of accuracy. The next project we're going to be dealing with is actually called fingerprint liveness detection. Now, something that you may have heard in the newspaper or various things, you may have heard scenarios that where there are people who are attempting to compromise the UID system by using various kinds of non-live fingerprints. Okay, like something like using Fevicol or polymer or any other such method. And there are many different materials and many different things where people. So therefore, we basically built a system so that we can identify the difference between a live human fingerprint and a non-live fingerprint. And this is using deep learning. We have actually done this, and this works on all the existing sensors that are there with UIDI. And we have done this and we have actually built this kind of system, and we've achieved an accuracy of over 99% in detection of any kind of these fake fingerprints for a whole bunch of non-live materials. And it's a highly scalable infrastructure. And we are actually moving towards that every single authentication, Aadhaar authentication done will pass through this liveness service. So, so therefore, this process is going on even as we talk. All the every single authentication that is happening in the country is actually going to do this. And many operators and many devices where these kinds of activities have actually been caught by Aadhaar. So therefore, and these are various kinds of models which are detected by, and this is something now that every single authentication in the country is actually going to use the liveness model, because it has been generated and it has extremely high accuracy and runs in a few, in less than 100 milliseconds. So to give you an idea of how fast this thing. Now, unfortunately, I don't have a demo of this. Otherwise, I would actually show. But this is something which is live and running at a very large scale in the country. So the next project, which actually is a very interesting project, which is again, is actually we are actually building what is known as today, if you know that Aadhaar is actually depends on what is known as biometric deduplication. Now, most people may not know what is biometric deduplication, but biometric deduplication means that today, if somebody enrolls for Aadhaar, then basically their biometrics are compared against the 1.3 billion people who have the Aadhaar today. And then that actually happens it's extremely fast. And basically, if there are obviously, if we are generating 1 million Aadhaars a day, then we actually do 12,000 trillion biometric comparisons in the Aadhaar center every day. Now, some of these deduplication systems that are built are actually, we are actually they are built using software, which is software from various non-Indian companies. So therefore, the goal is to actually create a indigenous billion scale deduplication system within Aadhaar. And so the goal is to design a system which is better than the existing systems that we have, and completely using AI and deep learning to do this. So therefore, it has to work on a gallery of billions. It must have more throughput of more than 1 million identities per day. And it must be modular and handle all the various modalities and algorithms that we have. And it has extremely stringent accuracy requirements. And the interesting thing is, the reason we can do that is that if people understand what is AI is about data. And in this one area, obviously, we have more data than anybody else in the world, right? So therefore, we must be able to build the best system in the world, which is better than any other system that exists. So therefore, that is really the, that's the goal of this indigenous billion scale deduplication system, which is an ongoing project. There's not a project which has come out yet, but it's an ongoing project where we're actually building a billion scale deduplication system in indigenous system within Aadhaar. Yeah, this system actually has many different pieces that are there, that for each modality, you have to actually do segmentations, understand the quality, you need to do liveness detection, you need to do templating in different kinds, and then you need to do a very large scale, large scale biometric search to actually determine whether a certain biometric is a duplicate or not. And I think that we're building pretty much all the components of this system. We are now actually being able to use deep learning, AI, to actually build each one of these components and combining them. And so this is one of the things that if there were 5 years ago, we could never have attempted to try to do something like this. Today, we actually, we have to do a lot of work ourselves. We are not saying that, and we have this project along with the IIIT Hyderabad where we're working on this. But again, it is our young professionals who are actually using this to actually build these kind of billion scale models to actually do the entire deduplication in Aadhaar. And here are some of the early results that basically, by combining we can actually build a deep learning based matcher. And we are using something that we're actually coming up with a completely new way of representing fingerprints, which is a fixed length representation of fingerprints. And in this method, we are able to see that we are able to get the accuracies that should be, should be good enough to actually use this system to actually deduplicate at a billion scale. And, and I think when you combine modalities, as you see that we can actually get a false non-match rate of 0.01% in a 1 in a billion kind of false match rate kind of scenarios using this kind of technology and actually combining all the data that we have. So we're actually quite optimistic that we actually can create a system which can work in parallel with the other systems that are there. And so therefore we will actually have this piece of core technology will become indigenized as a part of this process. These are some more things, each of the individual components in there. There are lots of things. This is an example of a segmentation thing. We are pretty much, when we do these segmentations using deep learning, we are now significantly better than the other systems that are there. So we can benchmark each parts of our system. As I said, there are about 20, 25 piece parts of that system. Each part of the system, almost all of them have become deep learning problems. And in each one of these deep learning problems, we have been able to achieve kind of a state-of-the-art accuracy. And we'll have to do something like that to create a system like that. Open source is concerned, the original starting point of the work is open source. We have built things on top of that, and now that becomes obviously the IP of the UIDAI or Government of India. But the starting point is always open source that we have been working, and we are looking at all the latest research papers. We study them, we implement them, we modify them for our users. And this face recognition, if you are an AUA, then it will be a regular authentication capability which will be available to you. That if you have access to the Aadhaar APIs, this will become something that will be available to all the AUAs. other area that we have been working in Aadhaar itself has been the area of document validation and OCR. And so therefore, one of the things that you do, and this is obviously true in various government departments, that basically anytime you get a document, you want to validate the ID document with a minimal manual intervention. So therefore, we are basically building systems from various kind of ID documents and actually various kinds of ID documents to actually extract the required information such as name, address, date of birth, etc. from those documents, and actually compare that with the text information that is actually there, that has been captured in the client. And what this can do is that it can give you an early feedback to reduce rejection and manual typing errors. And also it actually speeds up the Aadhaar generation itself, because many of these QCs can actually be done in the real time. So there are a number of different kinds of things that are there. Obviously, we have first got what is known as the Roi detection. That this is just shown as a PAN card. These are, again, this is CTPN is an open source tool which is actually being used to do the Roi detection. It can be doing in any text. It can actually identify in any document as a box, as a location of text. And then once these texts can actually be passed on to different OCR models, and we are actually getting extremely high accuracies as far as the OCR models, both for written text and certain forms where there are handwritten text that are there. And this is, and also, so therefore actually we can extract this information, and therefore we can automate the whole process of document validation to a certain extent. Now, there are more complexities in document validation, which I will not go into today. We'll only talk about how the AI is being used to actually validate documents, what is printed with what is digitally provided. And this is something which is obviously can be used in separate projects outside of UIDAI. We are working on these even in other scripts and things like that. So this is another interesting kind of thing that where we have used AI to actually do this. So one of the things that if you understand Aadhaar, that basically as far as adults are concerned, you can do the deduplication using the biometrics. But for the children who are under the age of 5, we actually don't have the deduplication. That is the deduplication is not possible because they are not submitting the biometrics. The only biometric that they are submitting is the face. So therefore the interesting thing is that we built a demographic-based deduplication, which is validated by face authentication for actually determining, for example, duplicates among children. So this is a very simple example of a child where there are two different enrollments, and you see the photographs are different and not of very great quality either. And if you look at the demographic information, also it is quite different. The demographic information in all of these things. So therefore, the interesting thing is that we've actually built this demographic deduplication engine for children, where basically we can identify possible duplicates with high similarity scores, which are then actually passed through a face matching algorithm to identify duplicates in there. So this is an interesting mechanism. Again, using AI, using open source AI, we have built this system for demographic deduplication. The other one is actually is at a billion scale. We have built models for actually age and then gender prediction. And the use case, of course, is to minimize the errors in the age and gender at the time of enrollment, as well as kind of identify certain kinds of fraud where people who are of an older age are actually trying to enroll as children. And so therefore, and then of course, these are the kinds of things. So we built again, there are existing models, but we benchmarked and we built models and we trained them on our data set. And we are basically able to, given a photograph, we can kind of approximate the age within about 3 years, within 3 years of the age. And we also have an extremely high accuracy as far as the prediction of the gender is concerned. So again, obviously, all of these things are automation to actually improve the quality of the various services that UID is providing. I'm going to change a little bit. So therefore, now this is a second hat that I wear, which is a completely different hat. So I also heading up the AI efforts at Step Foundation. Step Foundation is a non-profit in the space of education. And the goal is that, and I think that Step Foundation does a lot of things in education, but basically my interest has been leveraging AI in Indian languages for public good initiatives. And of course, our goals are use only open source frameworks. And of course, everything that we do, all code data sets and methodologies are open sourced, and they can be leveraged and used by any entity. So that's the difference here. In the previous thing, the things that we have done was obviously we started with open source and we built certain things at UID. Now those are obviously the IP of UID, and UID will decide that, you know, if through a AUA license they are exposing or however they're exposing, that is how that works. Here, this is a little bit is a foundation where we are doing everything using, not only are we using open source, whatever we are doing is also open source. So that is the difference in this scenario. And the main things are literally in the area of language, and that is really where we are focused on most of the things. So there are 3 projects that we will be talking about here. Okay. So the first project that we are going to be talking about is actually speech recognition in Indian languages. And so therefore, you know, there are many speech recognition software that are there, and many different things that are there. What is different about what we are doing? I think the interesting thing is that we are open source. And open source, not just we are our code is open source, our data sets are open source, our models are open source, and our utilities are open source. Anybody can use it. And we want to actually build open source end-to-end recipes. So we believe that language belongs to the people, right? So therefore, language belongs to the people. So we actually want to actually create recipes so that people can actually build their own, speech recognition systems. And at the same time, we also want to get state-of-the-art results. So we're actually looking at some of the latest frameworks that are there in latest frameworks, as well as end-to-end speech recognition frameworks that exist. And our goal is to create the maximum coverage of Indian languages. So that is the goal as far as, you know, our speech recognition goals are concerned. So the interesting thing is that, and we will talk through a little bit about it, that we have actually built some kind of speech recognition utilities in a number of different languages, in Hindi, English, Gujarati, Telugu, Kannada, Tamil, and Odia. So therefore, the interesting thing is we are actually able to achieve quite good results, and I think quite excellent results. And we were also, among the other things, in most of the cases, our transcription is better than what you can get from some of the commercial tools. And we're also the winners of the Indian English ASR challenge hosted by IIT Madras recently for transcribing NPTEL lectures. But in various languages, WER is what is known as a word error rate. So that's the word error rate has been achieved. We typically, a lower word error rate is better. And in a number of different areas, we are actually able to get a word error rate which is significantly better, completely starting with open data and open source to actually achieve this. And that's something that we're done. We have obviously got a number of different things that we've used, number of different methods to actually collect data, to actually build a speech recognition model from scratch. One of the big things is that we believe that we've reduced the time taken to build the life cycle of a model for a given language. We can build a model within a few months. And we have got a number of different things where we basically are able to crawl the web to actually get creative common data, which can be used as input for our pipelines. And we have also created a crowdsourcing initiative to basically get a whole bunch of data for speech recognition analysis. And the other thing, of course, the big thing is that we've built lots of AI tools actually to clean the data. That's one of the most interesting things that we do. So we to clean the data, to basically identify data diversity, genders, dialects, age groups, and so various kinds of things. So that's, I think, one of the powerful things are the automated pipelines that we've actually done to. So as a result of this, we've created, for example, we have created over 2,500 hours of data in Hindi, 1,088 hours, and this is work in the last few months that we are able to create large amounts of data, and so that's another part using some of these techniques. So, and overall, our modeling process actually involves lots of interesting things. So we actually have two different methods to collect data. One we said was crawlers using basically to collect open source data. And then we do various things like cleaning, where basically we identify whether the language is correct, whether the songs or music or the signal to noise ratio is right, or what is the situation. And we also do various kinds of cataloging and filtering, where what is the number of speakers, because you want enough speakers, gender, duration, and transcription. And the second part is, of course, is something that which is where we are actually trying to crowdsource data, and this is actually where basically we can actually collect data from a large number of people and actually use that crowdsourced data to train models. And this is inspired by Mozilla has a project known as Common Voice, and it is based on that project. And after that, we've also built the recipes to actually train and to train the models as well as fine tune the models. So one of the big things that has happened, because we have used basically what this the concept of semi-supervised learning. Okay, this has been by the way, one of the big things in AI, which everybody talks about, is I need to have data, and then the second word that is they need to have labeled data. So one of the things that we have done, but in the last 2-3 years in AI research, a big topic has come up, which is the topic of semi-supervised learning, which basically says that I can actually use fairly small amount of labeled data, and I can basically use unlabeled data in large amounts. So for example, in the area of speech recognition, that means that if I just have a lot of audio clips, that is unlabeled data. If I have audio clips and the corresponding transcription, that is labeled data. But I can work mainly with unlabeled data, but a small amount of unlabeled data to actually get very good results in the area of speech. And this is something that in the last few months has become important in various has given very good results in English and German and things like that. So we said, let's take that process and try to build it on Indian languages. And we are getting very, very interesting results as part of that.
Hello, everyone. Let's take a look at our Inference website. So currently we have integrated models of 7 different languages in our website. So by choosing a language and speaking over the microphone, we get their corresponding transcriptions as output. So I have a few sentences with me. We could try them out one by one and see their results. Let's start with the English model first. Okay, ready? The solar system consists of Sun, Moon, and planets. It also consists of comets, asteroids, and meteoroids. The Sun is the largest member of the solar system. In order of distance from the Sun, the planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay, so the results seem to look good. And, let's move on to the next language that I have. Let's try Hindi. वन और पर्यावरण का बहुत गहरा संबंध है। वन जीवनदायक है। यह वर्षा कराने में सहायक होते हैं। धरती की उपजाऊ शक्ति को बढ़ाते हैं। वनों से भूमि का कटाव रोका जा सकता है। इससे ध्वनि प्रदूषण की भयंकर समस्या से भी काफी हद तक नियंत्रण पाया जा सकता है। So please take a moment and validate these results. I think it looks promising. Are there any typos? I don't find any. Okay. So I would like to speak on one more language. Let's try Tamil. This is the last one. Okay. பொங்கல் விழா தை மாதம் முதல் நாளில் கொண்டாடுவார்கள். அதனால் பொங்கல் விழாவை தை பொங்கல் என்பார்கள். If we have any Tamil speakers here, I think there are no typos in here. I think we've got the exact transcriptions as per the audio. Yeah. So this was it. This was the demo. That's it from my side. Thank you.
Just wanted to share this. This is completely, just to give an idea, this is completely open source code. And our goal is actually to try and build models in as many languages as we want. And we want to actually try to give these models to the community so that they can use it for whatever purpose they might do. So the whole point that we are saying is that this. We think that at least I personally believe that language belongs to the people. So therefore, we need to be able to create good enough things that anybody can use for any purpose and can be used for anything that's there. And here we are going to talk about Project Anuvad. Okay. So Project Anuvad is also by Xstep Foundation. It is also the goal. The goal is here is actually translation in Indian languages. And the goal is conceptualized by translation capabilities in Indian languages. It is open sourced, and it is available under the MeitY license. That is available under the MeitY license. It is again it is funded by Xstep Foundation and uses the neural machine translation technology to achieve state-of-the-art results. And our goal, Anuvad, is really got three different things. We are continuously tuning our translation models and making them better in Indian languages. And in fact, we have a collaboration with IIT Madras for the same. And we are actually also trying to build parallel corpus. So parallel corpus is something which is very important in the area of translation, which means that you have the sentence in one language and you have the same sentence in the other language. And that actually helps training these AI models. And so therefore, one of the things, both in the speech project and this project, creation of data, because I may have a model today, which is good. Tomorrow, somebody else's model may be better than my model. And the point which I want to, and by the way, in all of these AI things, I want to say, I am not saying that we are anything that we have some, fantastic technology. We just want to say, anybody can do this. You must want to do it. We can do it, and we can build great results. That's the key message that I want to send. I don't want to send any result that. And then, of course, we want to. The next thing. That's why the parallel corpus, the data set, is so important, and making the data set freely available so that people can do things. And then, of course, we also want doing work in building productivity and metrics. So we've actually built a tool for translators so that they can effectively leverage all these technologies. So one of our visions is, of course, is to create, and we are hoping that that we will create the world's largest repository for Indian languages for parallel corpus. And we have done this for a large number of pairs. Again, we are scraping data from various places, whether they're legal data, where legal is actually one of the important domains we are working on in translation, whether it's government releases or general news articles and press releases and religious books, etc., or it is education, etc. So therefore, we are actually working in a number of Indian languages, and our goal is to create, and we actually create these. So today, for example, I have a release from, say, PIB, Press Information Bureau, and it is there in various languages. But if it is today, it's not accessible. So we do various transformations, and we convert it into a parallel sentence, and we actually use AI to determine which is the parallel sentence in the languages that we are interested in. So we are actually create large numbers of parallel corpus using AI tools and using various pipelines to do that. And then, of course, in translation models itself, we have built 9 models for some of the largest Indian languages. And we are looking at different architectures. We use OpenNMTXL, we use MT5. Whatever the latest model is, we will use it. We'll actually keep looking at it and keep seeing how it impacts. And then we keep collecting data. Then, of course, for the same model, having more data improves the result. And we have a collaboration with IIT Madras, 2 young professors who are actually doing very exciting work. And we were very proud to work with them on some of these language things. And we continuously evaluate our models against commercially available tools. And we have in-house translators to actually compare the accuracies. On top of that, we built productivity tools, which are again also open source, where we can score every single sentence that is created. We can, a whole bunch of statistics and dashboards are available. We can control the translation by doing domain-specific glossaries. We have sentence memory. We have a very interesting concept called interactive translation. And we see that these can actually improve the productivity of real translators by about 4 times. And we can actually now do approximately 650 to 700 words per hour as far as the productivity of a translator is concerned. This has actually been, the tools that we have developed has actually now been adopted by the Supreme Court to actually translate orders, judgments, and sentences. And it is now used by 18 courts and the Supreme Court translation cell for 9 different languages. We actually use, the numbers have gone down a little bit on the during the pandemic, but we are at approximately 2.5 lakhs per month is what is translated. And then we have actually released a new version of this software recently. We've also actually it's interesting that we've also worked with the Ministry of External Affairs to actually also release this in Bangla, specifically for the Supreme Court of Bangladesh. And so that's another interesting thing that so much of the translation that work we are doing is actually in the legal domain, but actually many of the tools we build are kind of generic. The last project that I want to talk about is a project known as Project Saral. Project Saral is also an open source project which is funded by the Xtep Foundation. This is actually a very simple project. It is unbelievable how simple this project is, but it actually is for mark sheet scanning. And we have actually worked with the Department of Education in Gujarat and in Uttar Pradesh to actually scan. So therefore, what happens is that this is an example of a sheet of there is both the weekly tests as well as the semester tests, and each of the tests the mark sheets are actually entered, and these are scanned, and so therefore you have digital information at a question level as to what each student is doing in each subject. And this has actually been rolled out in Gujarat in a fairly large scale, and also been rolled out in Uttar Pradesh. So all schools, the weekly tests are actually using this system to actually digitize the marks that they are getting, that students are getting in every test. And because each question is linked to a learning objective, you can understand which student knows, is familiar with addition and subtraction, or which student knows place value, or those kinds of things. So actually it leads to very, very extensive analytics. And this is something which is a very, very simple system based on OCR, which we actually built. The application itself in the last 6 months has 100,000 downloads, and 309 million records have been sensed and analyzed using in Saral in Gujarat. And basically, 43.5 lakh mark sheets have been done, and 74 exams have been conducted since July 2020 to January 2021. I will end with a video of the usage of this application Saral. It is actually a YouTube video. It's a viral video, so I will just share it. So what is happening here is that there's a phone, and then the person has made this box. I'm sorry, I think you got an idea that basically all teachers in every class test, weekly test in Gujarat are actually using this app to actually digitize the marks, and therefore the student performance is being understood at a much deeper level than was ever been able to understand before. Therefore, there are 2 things that we always start with the different open source systems. There are many open source face recognition systems that are there, but we start from the source and we train on our own data to actually get more accurate. So we are not trying to use some kind of API from somebody else. No, this is our own thing that is actually built and trained by us. Okay. We are using face authentication. We are not doing face recognition. Face recognition means something where the person is not consenting to actually getting authenticated here. We are actually doing a match with the with the face, and you're actually giving the Aadhaar number. And that is how this works. That is a one-to-one match where the person is actually consenting to the authentication, which is the difference there. And so therefore, and certainly as far as Aadhaar is concerned, Aadhaar is supposed to do only, Aadhaar Act is supposed to do only one-to-one authentication. The authentication that we are doing is face authentication. Aadhaar also has iris authentication, which is also there. It's something that has been there in the past and continues to be there. But this is actually face authentication using a regular camera on a regular. That's a big thing about face authentication is the device. You can use a very common device and use this. We are not using deep learning at all. We are just using in the authentication. Face authentication is one of the modalities of authentication in the CoWIN app, which is being so two things. There is never so in general. Few hours after for a few hours after their death, yes, you could probably use a fingerprint and identify, but then there's identification, so that's not possible in the Aadhaar system. That is not what it is built to do. But for a few hours after their death, the fingerprint can actually be used for identification. The answer is that it will be available as it is going to be available in the same way as fingerprint and iris authentication. So it will be as a it will be you know, if you are an AUA with Aadhaar, and I think that these kind of applications can be available for that also. Yes. We are using many different things. That is also the beauty of using. The beauty of using AI. If there is any specific things, I can if you are asking about which particular thing, I can tell you which algorithm we are using. But in different areas, we are using different ones. If someone wants to reach out to me specifically and on a specific area, I shall be glad to point out, because all these are open source. They're open. There's nothing to sing, and we are using many different kinds of things in different kinds of models that we have used. When we are talking about any work that we do at Aadhaar, it is governed by the Aadhaar Act. That is the legal framework under which that we need to work. So everything that we are doing, everything that we do is completely compliant with the Aadhaar Act, and that is how we operate as far as Aadhaar is concerned. If you're talking about general how AI is being done for ethical AI and other things, those are bigger topics that go beyond a given individual organization, and obviously those are bias and all those things they are talked about. But I think that those are bigger than this individual presentation. You know, with face recognition with identical twins are more likely to be actually identified as you may actually get with identical twins. Face recognition does not work that well because obviously the face is quite similar. But there are obviously, when you use any time of authentication, you should obviously use it as, especially if it's a very you know, kind of a critical transaction, then you should try to use multi-factor authentication in that case, because obviously things like fingerprint and iris, etc., or mobile number or whatever, all those things are different. So therefore, face authentication works very well, but one example of a case where it does not work so well is certainly identical twins. It depends upon the kinds of things that obviously for training of models, we do have certain GPU systems, etc., which we have within here. But you know, I think that the interesting thing is, it is nothing that tomorrow I mean, and when we get to the second part, right, in Aadhaar we have certain GPU systems, but in the second part I am working with Ekstep, where we are actually just using the cloud. So therefore, yes, we will get machines which have GPUs or TPUs on the cloud, but this hardware is easily and openly available without much difficulty to solve these kinds of problems. So therefore, it is not something that is but many of the services are actually running on regular servers. There's nothing special about it, and certain kinds of work are also being done in the like, for example, the face authentication. Many of the models actually run at the front end on the mobile phone. So so it depends on there's a variation of things, but it is nothing. It's now not fancy hardware. It is now hardware which is becoming kind of standard. These are all general in image processing algorithms. Actually, the world of image processing, especially with the things known as transfer learning and all, has gotten very, very interesting. And there is actually and you see that there is so much similarity between various kinds of things. Yes, you certainly can build a model. Now, you can't use the model we have and use that for skin texture, but using the same concepts which are there in all these image recognition algorithms, which are fairly standard, and you can actually tune them for your problem, and you can actually use it to detect skin texture. I don't know the specific purpose for which you are doing skin texture, but it is certainly doable to do skin texture. The voice is a known biometric. It is not of the same accuracy as that one. As so traditionally, fingerprint and iris have been considered the most accurate biometrics, but in the last few years, face has really improved and has coming to the class of fingerprint and iris. I would say in the last few years, voice is not at the same level of accuracy, but certainly voice is a biometric. And it's a very interesting biometric, because if I only have a phone, I can only do two things, right? I can use my face, and I can actually speak. So it's a biometric which is available on every device that we are expecting everybody to have. So that's why actually voice is a very interesting biometric. Its quality hasn't yet reached the quality of, and by the way, I want to explain that when we are talking about voice, there are two different things, and people sometimes get confused between those two things. The first thing is what is known as speech recognition, which means I am saying something and the system is understanding what I'm speaking. Second part is speaker recognition, where it is not what I am speaking, but who is speaking it is what is there. And so therefore, there are certainly this kind of, in fact, in some of the other works, I'm building some speaker identity models and other things. But, I think that voice is also an area which is a very interesting area where things will happen. No, we are not using 3D face authentication. Obviously, 3D face authentication requires all kinds of special requirements on your devices and all of those things. One of the goals is to actually provide, systems that are widely usable. That's the important thing, that are widely usable. And so therefore, that means that I would like these systems to work on traditional devices that are commonly available, and not something that is having said that, 3D face authentication, if the hardware is provided, you can do those things. But I think in a scale of doing authentication to a country like India, I think 3D authentication may not be the right way of. If somebody enrolls for Aadhaar, you see that. Let me go back a few slides if I can get there. Wait a second. So yeah, sorry. Yeah. So therefore, when you actually put your finger on the slap scanner, what you get is this image that I'm showing here with all the 4 fingers. But what is actually used for the deduplication to find out that unique identity is actually the part which is in the box, the red, yellow, the red, blue, green, pink boxes. And that is actually that is what is used for the actual identification of the person using the fingerprint. So segmentation actually takes the entire image that is captured and identifies the part of the image which should be used for your identification purpose. in fact, that is always one of the reasons. So when we build a system like this, at least, the intent is inclusion. So when we bring other modalities, the whole purpose is to include everybody in the system. So therefore, that is really yes. So you are absolutely right. There are certain children where fingerprint is, or certain people, they may be old people where the fingerprints may be worn, or certain other things. And therefore, when you have more modalities, you have different ways of authenticating people without authenticating people, even if some modality is not working. And similarly, the situation could be even, but and I think that that's very important, that irrespective of what is your disability or what is your things, the right to Aadhaar is absolute, that everybody can have an Aadhaar. Okay, so therefore, just because something is there, they should not be excluded from Aadhaar. That is very important.
Begin a policy call, because right now the policy says the biometrics, the fingerprints and the iris.
No, sir, but there are exceptions. There are exceptions, sir. The policy also very clearly says that if they don't have, then the exception is available.
Yeah, and well, ultimately it will have to replace the photograph, which is normally taken.
Yes. Sir. The definition of what is a biometric is any feature that actually does not change over time, or whose change over time you can understand what is happening. So that is anything is a biometric. So something that is innate in the person could obviously be considered to be a biometric, but it depends on what is the system. In the Aadhaar system, these are the three methods: the fingerprint, the iris, and moving forward, the face are the methods of authentication and the methods of deduplication. But if you are talking about a general theoretical biometric system, any methodology that helps to identify obviously increases the likelihood or the confidence that you are able to identify somebody. So that depends on a different system. Of course, it can be used, but not in the Aadhaar system as it is defined today. So the thing about it is two things: that nothing, as far as Aadhaar is concerned, that all the data is basically stored within the CIDR data centers, right? That's how it works. And that is when you enroll for Aadhaar, that your enrollment data is there, or when you do an update, your update data is there. When you do an authentication, in fact, one of the very important things in Aadhaar is that the control of the capture, or whether it is fingerprint or iris or face, is actually not in the AUA application. The AUAs don't have access. In fact, it is already encrypted and signed before it reaches the AUA application in what is known as a registered device service. And then that comes to the UID data center. It is then used for matching against the information that we have. And according to Aadhaar Act, the authentication that you have is actually allowed to be stored only for 6 months. And after that, that authentication record is actually deleted and doesn't exist anywhere. So it actually never with the AUA. It is with UIDI only for 6 months in basically accordance with the Aadhaar Act. And of course, the original enrollment and this thing data is available within the Aadhaar data centers. Voice recognition is, everything when we say is unique, it depends on, you can definitely understand the voice of a person, and you can actually, it depends upon out of how many people, right? So therefore, voice is not as good as face as this thing, but certainly if, for example, in addition to some other modality, supposing you say you actually gave the Aadhaar number and then you gave the voice, and then you can probably with a good accuracy say that voice indeed belongs to that person. And in addition to that, you can also create things like challenge response, etc., which you can make a good system using voice. I think blockchain is not, blockchain is not necessarily the best way to actually decentralize data, but we do understand there are concepts such as known as federated learning, okay, is a mechanism where AI can actually work on decentralized data. But today, the performance of AI algorithms on federated learning is still not as good in terms of the final result and accuracy that you get. But that is something that can be looked at. But if you look at it, India is coming up with this basically the personal data protection bill, and in there a lot of things are being talked about as to how the data of Indians should be safeguarded. And I think that there will be some talks about both personal data as well as non-personal data and how these things will work. And I think that it is obviously a challenging area. And I think that, but I don't think that blockchain necessarily as it stands may be the right way to decentralize the data. But I don't know, tomorrow technology may change and that may also become possible. But today it's probably not, a little bit overkill. Yeah. Absolutely, that in general you want to have a punctuation model. As I said, we have not built a punctuation model into what we have, but we definitely are planning to do that. So you will definitely have full stops and capitalizations and question marks and those kinds of things will also show up. It is obviously not something that is actually spoken by the person. So it is not the default output of the speech recognition model, but you can apply another AI model on that to add punctuation on speech recognition.
Then the question is, when can we replace Google Translator APIs with Anuvad on your mobile phones?
No, so I think this is a question. This is not a question for me to to not a question for me to answer, but I think the point is this. I think all these Google, Microsoft, all of them do a wonderful job. And I think that is the point that, but having said that, our language is our language, right? So therefore, that is why we have to, if we are being Atmanirbhar, we should be Atmanirbhar in our own language. I think that's an important thing, but there is a role for all of these things to play. And I think especially for various things that are our services that our government are publishing or our startups are building, this should definitely be an alternative that they should consider and they can use. And I think if we put the effort, we can be as good as anyone in these things. That is the key point that I want to say. Ki aisa nahi hai ki that only that they are doing something magical. Hum bhi kar sakte hain. And I think that it is something which is very important that we should have the pride in our own languages. This is a strange question. No, as far as UID is concerned, everything is absolutely controlled by the Aadhaar Act. So I don't think that is a possibility. But getting a lot of ASR data is not a problem. So yeah. So there are various methodologies that are there. So if you look at it, typically in English, like single-digit word error rates are quite common. In India, in Indian languages, if you try to be very general in things, it's still a little bit not as good. But there are two reasons. One is that, of course, there are smaller when you do the measurements, there are smaller errors show up a little bit more. But as you saw in those two examples, we can get quite a good transcription in Indian errors. But when you look at it, depending on the scenario, you're probably around 10 to 15% errors are probably there in the words. But still, the words are similar, close enough that you can fix them. And as you get more data, why should the Indian transcription not be at the same level as English transcription? There is no reason. And that is just hame kaam karna na, if we want to make sure that we have this same accuracy. And that is our intent and goal. At least my personal goal is I want to do things in Indian languages that make it as good as any other language. I think this is a very good question. So GPT-3 is not just India. I think it is just a few, the GPT-3 is not an open source model at all. It is doing very, very interesting things and people can use it. But in fact, this is the kind of a class of things, basically, none of us have the kind of hardware to actually build those kind of GPT-3 में कुछ special नहीं है. It is just you put that much data and you put that much compute and you build something. So the question is, the right question to ask is, will there be available the hardware? Right now, this is not the kind of hardware that I can even get on a, if I go to the AWS or Google Cloud, I cannot get that kind of hardware. So if we actually saying that we want to build so one way is कि ठीक है यार, let us use the GPT-3, दुनिया बना रही है, हम भी use करेंगे, and we can do a lot of interesting things. But if you are saying कि हमें भी बनाना है उस तरह का कुछ, so then you need a very, very significant amount of compute, which is much bigger than what at least I can afford, and we can afford in the places where I am at. But it is nothing special, but it is wonderful that basically what it's showing is, जितना ज़्यादा data डालोगे, you can actually get very, very interesting results. Obviously, if there is a drastic change in the face, there can be possibilities that it may not work. And with age also, I mean, the hardest part in age, just to be clear, if you took somebody's photograph when they were 2 years old, and then you took it when they are 12 or 13 or 15, it's much harder to actually face authentication to work. But once you're an adult, the changes, there is slight degradation in accuracy over time. And so therefore, obviously, you could have updates and other things of the face to solve those kinds of problems. But still, accuracy is very good once you become an adult. So say between 15 years and 50, 60 years, things are actually quite stable. There are two kinds of face authentication that you have to look at. If the goal is for you to hide from the authentication, right? That is a kind of that's a different game, right? Malagi, if you don't want to be identified, right? That is the question. If you don't want to be identified, that's a different question. You can obviously, Amitabh Bachchan can look like anybody. Then if they're looking something different, then to expect the face authentication to work in that time is is quite hard. But if you're talking about the natural variations, I was clean shaven and I have a beard, those kind of things, the face authentication can manage. Glasses, there are slight, reductions in accuracy, but glasses, those kinds of things are actually not that much of a problem. Now, for example, it is interesting. Some face models, and not our model, we are not saying does that, but there are even models where nowadays when people have these kind of the face mask and all, can you authenticate with the face mask because you're only seeing part of the face. So all of these things are possible in theory in face authentication. So is it are possible, but it's a gradation. If you have a very, very serious change in you do a major plastic surgery and completely change your face, it may not be as easy. But so some of those things obviously do matter. But the intent is, because we are doing face authentication, it means that the person wants to be authenticated, which means that they are cooperative. They're not trying their best to, but normal variations, our algorithms definitely can manage.
I think we are coming to the end of this session. So so I would request Dr. Vivek to make any other remarks that you would want to.
So no, I think the point is this, that I think I think the thing that I would say is, first of all, thank you very much for giving me the opportunity to speak here today. And I wanted to speak specifically for the use, so that we use open source AI and we build things ourselves. And I think that is I'm hoping that we can inspire some people to do. Itna mushkil nahi hai, is all I want to say. And AI mein, there is a lot of exciting things going on in the world, and we can use the best things in the world and use it to solve our problems in India. And my goal is that if we can use some of these technologies to make governance in India better, then that would be very exciting for me. And I think that there is opportunities, and everybody should try and work and contribute towards the same.